Hello, my dear students. Hope you are all well. In our previous class, that is tutorial 7, we have discussed some general methods of preparation of aldehydes and ketones from primary alcohols and from secondary alcohols. That is, aldehydes, we have prepared aldehydes from primary alcohols with some special oxidizing agents, and we have also prepared some ketones from secondary alcohols with the help of some special kinds of oxidizing agents. In this present class, we are going to discuss some general methods of preparation of aldehydes and ketones from Grignard reagents and from others. So, at first, we are going to discuss we are going to continue with the Grignard reagents, a very special kind of reagents and used frequently, and it is a very useful reagents in chemistry, especially in organic chemistry. So, what is Grignard reagent? At first, from Grignard reagent. So, general methods of preparation of aldehydes and ketones from Grignard reagent. Please follow this class, Grignard reagents. And again, I request all my students, if you think yourself benefited from this class, please subscribe my channel to get some updates of chemistry classes. Okay, so from Grignard reagent. So what is the Grignard reagent? What is the Grignard reagent? Grignard reagent. What is the Grignard reagent? And I'll suggest to all of my students to please write down the notes. Okay, what I am writing on the whiteboard, please uh, write down all the topics in your copies by pausing the videos. Okay, otherwise you will all forget this. So Grignard reagents, what is the Grignard reagents? Chemistry is not a very difficult subject, but only you have the thorough understanding, you have to retain the thorough understanding. So, what is the Grignard reagent? Grignard reagent means RMGX. RMGX. This is the Grignard reagent. So, what is RMGX? R maybe alkyl group, or maybe an alkyl group, or aryl group. And what is X? X is halogen. X is halogens. That is, it may be bromine, maybe chlorine, iodine. Okay, so this is the Grignard reagent. So out of the Grignard reagent, we are going to prepare ketones and aldehydes. So at first, so you can understand what is the Grignard reagent. So I'll remove this. So please write down Grignard reagent, alkane nitrile, alkane nitrile, alkane nitriles. What is alkane nitriles? RCN. This is the alkane nitriles. Alkane nitriles, by the reaction with by the reaction with alkane nitriles by the reaction with Grignard reagents, by the reaction with Grignard reagents, followed by hydrolysis, produce produce aliphatic aromatic ketones. So this is alkane nitrile or aryl nitrile or aromatic nitriles. So if you start from aromatic nitriles, you will get aromatic ketones, and if you start from alkane nitrile, you will get aliphatic ketones. Okay, so let's show some example. That is C2H5CN. So what is the name? This is nitrile. Okay, so C2H5, if it reacts with CH3 Mg Br, this is a kind of Grignard reagent. Okay, so name of the Grignard reagent is methyl magnesium bromide. Methyl magnesium bromide, and this is ethyl cyanide. Cn means cyanide. Okay, so if it reacts with this cyanide or this nitrile, will react with Grignard reagent in presence of dry ether. Must dry ether. So what happen if it reacts with dry ether? It will be like this: C2H5 C double bond. That means the CH3 group, this CH3 group, this alkyl group will transform to this carbon, and it will like this Mg Br. And if you hydrolysis this H3O plus, after hydrolysis, this moiety double bond will be replaced like this CO CH3. Okay, this is the ketone. So it is C2H5. That means 1, 2, 3, 4. So butan, butanone. This is butanone. This is butanone. Okay. Next example, we'll see C6 aromatic nitrile C6. This is benzene. So and nitrile. So this is benzyl nitrile. This is benzyl nitrile. Benzyl nitrile. If you will start from benzyl nitrile and give it CH3 Mg beer and dry ether, what happen? The C6H5 C double bond N Mg beer, and here the CH3 group will migrate to this carbon, that is this carbon CH3 group. So these are this alkyl group will be migrated to the carbon atom double bonded with the nitrogen, and in the actually nitrile carbon. Okay, so the CH3 group of, repeat, I must repeat, the CH3 group or the alkyl group of the Grignard reagent, the alkyl group of the Grignard reagent will be migrated to the nitrile carbon, remember. Okay, so if so in both the cases ketone will be formed. In both the cases ketone will be formed. This is called acetophenone. This is called acetophenone. This is called acetophenone. So write down the notes. Next we'll get some example. We're going to discuss some examples of formation of aldehydes out of Grignard reagent. So, in case of ketone, the reaction should be started from the alkyl nitrile or aryl nitrile. But if you want to prepare aldehyde, you should start the reaction from HCN, hydrocyanic acid. Okay, so HCN, that is hydrocyanic acid, hydrocyanic acids, hydrocyanic acid by the reaction with by the reaction by the reaction with Grignard reagent, that is Grignard Grignard reagent, followed by hydrolysis, produce aldehydes. Produce aldehydes. Please write down. I will again suggest you to write down the notes. Write down the notes. What I'm writing in the whiteboard, you should write on your own copybooks. Okay. So ACN. So start ACN plus CH3. So main thing, the CH3 group or the alkyl group, right? Look, the CH3 group or the alkyl group of the of the Grignard reagent will be migrated to nitrile carbon, okay. So like this, H C triple bond N R, and in the Grignard reagent, this is like this, it will be migrated to this carbon atom and this. So the CH3 group will be migrated to that carbon atom like this. So H C triple bond N, and the total group Mg Mgbr, this will act as Mgbr, and this CH3, and followed by hydrolysis, that is H3O plus, you can get double bond CH3. So this portion will be aldehyde group, CHO group. So this is called propanal, ethanol. This is called 2 carbon. So this is called ethanol or acetaldehyde. Acetal. That means if you start the reaction from ACN, you will get aldehyde. If you start the reaction with alkyl nitrile or aryl nitrile, you will get ketone. Okay. Next, very important reaction. Very important reaction. Very important reaction. This is the Rosenmund reduction. Rosenmund reduction. So this is the Rosenmund reduction. By the Rosenmund reduction, the by this reaction, the acid chloride. What is the acid chloride? The main theme is the acid chloride. What is the acid chloride? Acid chloride means, or acyl chloride, acid chloride or acyl or aryl chloride. This group, remember, this group is called acyl group. Acyl group. So this is not aryl actually. This is acyl chloride. you will remember acyl chloride. This group is called acyl group. Okay. So if chlorine is attached, that is RCOCl, this is called acyl chloride. This is called acyl chloride or acid chloride. So this is the main reagent of Rosenmund reduction. If you reduce the acid chloride or acyl chloride by reduction means use of hydrogen. Hydrogen in the matrix of palladium or platinum or nickel. This is called palladium and barium sulfate. Palladium, barium sulfate. Just it will give in place of Cl you get hydrogen. Okay. So like this CH3, CO, Cl will get palladium, barium sulfate and hydrogen. Just you will get in place of this Cl only one hydrogen is attached. So acetaldehyde and ACl. Okay. So so why barium sulfate is used? Why barium sulfate is used? Because if you don't use the barium sulfate, then palladium hydrogen again reduce the aldehyde to the corresponding alcohol. Okay. So use of the barium sulfate. So what is the Rosenmund reduction? I'll again. So in this reaction, acid chloride or acyl chlorides will be acyl chlorides are reduced to corresponding aldehydes in presence of hydrogen palladium, where barium sulfate acts as catalytic poison and and boil xylene and boiled xylene solution is used as solvent. Okay. If barium sulfate won't use would not use if barium sulfate won't use, then then the hydrogen in palladium will reduce will reduce the aldehydes to the corresponding alcohols. So this is the use of barium sulfate. So barium sulfate here acts as catalytic poison. Okay, so barium sulfate should be used. Okay. So in place of barium sulfate, one thing I will share, in place of barium sulfate, quinoline quinoline and sulfur can also be used. In place of barium sulfate, we can also use, so substitution of barium sulfate is here. In place of barium sulfate, we can also use quinoline quinoline with sulfur quinoline with sulfur. Yes. Okay. So this is the Rosenmund reduction. Very often questions are asked from the Rosenmund reduction and use of barium sulfate. Why barium sulfate is used? In place of barium sulfate, what can be used? All these things are very frequently asked in your competitive exam, in various competitive exam. Okay. So next, some other examples of the preparation can be seen. So ozonolysis, by ozonolysis. Next is the example of by ozonolysis. By ozonolysis. By ozonolysis. Okay. So by ozonolysis, aldehydes and ketone can also be formed from the alkenes. Okay. So if you start from the alkene like this is the alkene, and ozonolysis. Okay, in presence of what? In presence of zinc and water. In presence of zinc and water, what happened? An ozonide is formed. What is the ozonide? This structure is called ozonide. So this structure is called ozonide. Then it will automatically dissociate it, and this part, two parts will be detached from each other, and these two parts will form the corresponding aldehydes and ketones. Okay, this part will form an aldehyde and carbonyl compound, and this part will also form a carbonyl compound. Let's take an example. Okay, this is the ozonite. So if you start from this CH3, C, CH3, this part. Okay, this part. If you start from this is, at first you have to write down the, you don't need to remember all the mechanistic pathways. Okay, so at first you have to write down the procedure of to write, how to write the ozonide compound. This CH3, this CH3, and this CH3 is that CH3. So this is the ozonide, and what, the hydrogen is this hydrogen, and this CH3 is that CH3. The ozonide compound then dissociate, this part and this part will be detached, and this part like this CH3, this will become CH3, CH3, and this part, look, this carbon, that carbon atom, and the hydrogen is that hydrogen atom, OCH3. So this part, as there is a hydrogen atom, look, if there is a hydrogen atom attached to the alkene carbon means the carbon at, to which the double bond is attached. So if the alkene carbon contains a hydrogen atom, then this side will be formed as an aldehyde, and other part where no hydrogen atoms are attached will be formed as ketones. So this is ketones. What is ketone? This is acetone or propanone. This is ethanol. So this is the almost the outline of the what, of the ozonolysis. Okay, so there are lots of other preparational method. In our next class we will see some other process of preparation of aldehydes and ketones, but today I must stop here, and I will request all my students, my dear students, please follow my class. You can, if you follow my class, you can crack some typical questions asked in your various exams, like various entrance exam for medical and engineering, in your board exam also. Okay, and please subscribe my channel. If you subscribe my channel, I'll get the all the motivation from my students. Okay, so very next day we will meet again, and till then, goodbye, have a good day.